Well, hello there and welcome back to another video. So today we are following along with Advent of Code, where we left off last time. This is day 22. So it's only 4 more days to go. That's really good, although they usually get quite difficult in the last puzzle. So we're gonna see how this goes. And again, the math is not working very nicely. Okay, so day 22, monkey map. So I see that we are continuing with the monkey theme. The monkeys take you on a surprisingly easy trail through the jungle. They are even going in roughly the right direction according to your handheld device's grove positioning system. As you walk, the monkeys explain that the grove is protected by a force field. Okay, some sci-fi elements here. To pass through the force field, you have to enter a password. Doing so involves tracing a specific path on a strangely shaped board. Okay, so this looks like it's going to be a grid problem, which I usually like. At least you're pretty sure that's what you have to do. The elephants aren't exactly fluent in monkey. Okay, and I'm pretty sure that means that some of this will change in part 2. The monkeys give you notes that they took when they last saw the password entered, your puzzle input. For example, this thing. Okay, and down here it looks like instructions to follow along. The first half of the monkey's notes is a map of the board. It's comprised of a set of open tiles on which you can move drawn dots, and solid walls, tiles which you cannot enter, drawn with hash. Okay, the second half is a description of the path you must follow. It consists of alternating numbers and letters. A number indicates the number of tiles to move in the direction you are facing. Okay, so you have a current direction. If you run into a wall, you stop moving forward and continue with the next instruction. A letter indicates whether to turn 90 degrees clockwise, R, or counterclockwise, L. Turning happens in place. It does not change your current tile. So a path like 10R5 means go forward 10 times, then turn clockwise 90 degrees, then go forward 5 tiles. Okay. You begin the path in the leftmost open tile on the top row of tiles. What? You begin the path in the leftmost open tile of the top row of tiles. Initially, you're facing to the right from the perspective of how the map is drawn. Leftmost open tile of the top row of tiles. So I guess the top row is this, and the leftmost open would be this. You start here, if I understood correctly. If a movement instruction would take you off the map, you wrap around to the other side of the board. In other words, if your next tile is off the board, you should instead look in the direction opposite of your current facing as far as you can until you find the opposite edge of the board, then reappear there. For example, if you are at A and facing to the right, so we are here, the tile in front of you is marked B. Okay, makes sense. If you're at C and facing down, the tile in front of you is marked D. Okay, so you wrap around in this like bridges of land, like islands of land. It is possible for the next tile after wrapping around to be a wall. Okay, yeah, I guess so. This still counts as there being a wall in front of you, and so movement stops before you actually wrap to the other side of the board. Okay, By drawing the last facing you had with an arrow on each tile you visit, the full path taken by the above example looks like this. Okay, so we are starting here, we're moving down, it seems, then right, down, and it wraps, and then right, and it stops there. I said right, but it's probably, yeah, this is a turning left because we are going down, but yeah. Okay. To finish providing the password to this strange input device, you need to determine the numbers of your final row, column, and facing, as your final position appears from the perspective of the original map. Rows start from 1 at the top and count downwards, and columns start from 1 at the left and count rightward. Okay, so we have one based indexing. In the above example, row 1, column 1 refers to the empty space with no tile on it in the top left corner. Yeah, so there's nothing here. Facing is 0 for right, 1 for down, 2 for left, and 3 for up. So it goes clockwise. The final position is the sum of 1000 times the row, 4 times the column, and the facing. In the above example, the final row is 6, and the final column is 8, and the final facing is 0. So the final position is this, which is 6032. Follow the path given in the monkey's note. What's the final password? Okay. Let's check the input file. All right. So it's a bigger map. It is very boxy, and then a very large list of instructions. Okay. So I'm wondering a couple of things, like if it makes sense to like how are we going to represent this? I think using the usual representation of like a 2D grid, like we probably don't need to worry about these empty things. And by the way, are these empty? Yeah, the lines here don't continue, but we can probably, yeah, it should be no problem. This, and by the way, also the wrapping around is, it said that, for example, if you are facing left here, you should go to the right as much as possible and reappear here, which makes sense. Although I'm wondering if you can go left, continue, like start from the rightmost place and go left until you hit something, and it would be the same. I think it would, because this map doesn't have any U shape or something like this. Like, for example, if you would have something, I don't know, if you have a piece here, like a U shape, and you go to the left, imagine that you have something here, you go to the left, I think the instructions said, okay, you would appear on the right of that like little island thingy or peninsula thingy, and that would be the correct thing to do, instead of appearing on the right and going left until you. But I guess it's the same. Like that shouldn't affect the, you know, the complexity of things. Okay. Yeah, let's jump into this. Let's try to at least try to sketch out part 1, and then maybe end the video and continue afterwards. So let's go to Advent of Code. because yeah, I wanted to do something at like 6 or 7 p.m. Let's close everything. We'll have day 22, which was monkey what? Monkey map? Yeah, monkey map. So we have quite a few monkey things. We have this, and let's create a new file. What did I do? I touched more than I wanted. .rs. So this will have a path function run that takes an input, string slice, that's a string. Okay. Let's copy the sample input. By the way, I was checking how to do unit test in Rust, and you can do something which maybe I can try out. This is the real input then. Would be this. Oh, look at that in the side minimap. You have a shape of the input, and well, here it's wrapping around, so it's not helping much. Maybe we can take a look at this, minimizing the font size, so we can have a better look at the shape of things. Huh. Well, it also changes unfortunately the same origin, so it makes the font size here kind of unreadable. So I was thinking about, I was speaking about unit tests, and they are surprisingly easy to make. So if you just make a function that says has the test annotation, and you say something like, well, function test sample, and let's put this sample in a constant, something like this. You probably need a semicolon there. I think to make this as like the same thing, it would need to be something like this. And then you run something. You can run anything here, but the idea is to put some assertion. So let's say assert equal, and we want to run this function with the sample. So run, I think we can, well, can we just use run? I don't know if we need to import the run or something. Yeah, it's just in the same module, so we should be able to. And if we say, okay, we want to see if this equals this, and then we can just say cargo test, and it failed. We should have some sort of assertion message. Yeah, it was empty, and it expected this thing. So maybe I can leave this, although it's complaining that sample is never used, and I think this is because it's never used on the how do you call it, the executable binary. And the idea is that you put these things inside of a test module, and we put everything in here, and that broke the formatting of this. And this, by the way, is how string literals work in Rust. Like, if you leave it like this, they will have this indentation, and they won't be the same as the file with that. So I think I will leave that as this, although I can also use like a separate file for the sample and do like an include string there. But let's leave it as this, and you can mark this module as something like config cfg test, I think it is. So it gets only included in the test runner. So here run, I think we need to refer to it. And yeah, you can do something like this, like importing. But I think you can also do something like super. Yeah, super run accesses the parent module, something like that. Like modules are nested things. Okay, so if you have that, and I guess if we hard code the answer, then we have a green test. And that way I don't have to shuffle between the sample and the real input. Let's try it out. Okay. So how do we do this? Actually, did I screw up I think I screwed up. Yeah. How did I screw this up already? Maybe having this in the source file is not the best idea. If I save it now, okay. Now it's fine. No, wait, it's not fine. It's not the same shape. What's happening? Oh, come on, text editor, don't try to be clever. It's breaking. Like it's converting this, I don't know how many spaces are here. So 4 and 4, 8, it's converting that into 4 spaces for some reason. Should I use a separate file for the sample? Maybe I could. Let's try that. Day 22 sample txt, and we can say let sample be include str, and this should be, I think it's relative to where I am. So inputs day 22 sample txt. Is this all right? If I put something wrong, do you complain? Yes, it complains. So I think if it doesn't complain, then it's fine. Sample. Okay, and we can have something like this, I guess. That was a bit complicated for what I wanted, but it's fine, right? It's compiled. Yeah, it's running. And I think it's pretty fast how it compiles for the unit tests. I don't know if it does like a fast build or something, but it feels faster than building the whole thing. So let's go with that. Not too much of a fan of having to include something external, but yeah, when you have files like sample inputs that depend so much on the white space. No, oh, the sample should not be this. It should be this. Yeah, and here it's not screwing around with the indentation. All right. Wait a second. Do you notice something interesting about this input? And yeah, look at that. The input looks very boxy, you could say, like very squarey, and I bet you this length is the same as this length vertically. Of course, we don't see it like that because characters are much taller than wide. But we can probably check it because I was checking this, and you can see this side is of length 4, and it's also 4 characters tall. And the same is true, like you can think of, so this is a like 4x4 square, and you can see that this map is made of 4x4 squares, and the big map seems to be also made. Can we take a look at not the sample? Oh, sorry, I'm screwing around. The actual inputs, which looks horrible. If we have this, so the selected is 50, and it goes from 51 to 100, so it's also 50 tall. Yeah, so this is a square of 50 by 50. And you know what? I think that's not a coincidence, because I think this thing, yeah, it looks very much like the faces of a cube, like unwrapped, if I'm not mistaken. Like you can wrap these squares into a cube. And so I'm thinking that part 2 will be okay. No, this map is not a 2D thing. It's actually an unwrapped cube, and you will have to, instead of wrapping around in that weird way, like teleporting way, you will be actually oh man, you will be walking on the sides of a cube. And yeah, I bet you that that's gonna be part 2, and that sounds very difficult, actually. Damn it. So I want to like sort of forget about that and try to solve part 1 as if nothing happens, and only try to think as simply as possible as this being a grid. But it will, yeah, if that's the case, and now it's impossible to not see this as it being the case, because these are like 6 4x4 squares, and this is also, if we take a look, it's also 1 2 3 4 5 6, yeah, squares. So okay, they probably will be cubes. Let's not think about that. Let's selectively forget about that thought and try to solve part A. Part 1, I mean. We want to have this number for the sample. Okay. So how do we do that? Let's say first we are going to parse this input. Or actually, first we should separate. Oh, there's an empty line here. Yes, there is an empty line. That's interesting. So we can probably take the 2 parts. Let's map part and instructions part the input split once, split once by double new line, and expect this input should have 2 parts. Then we're gonna parse the map and parse the input, parse the instructions, I guess. let's say, let's map or grid, or how are we going to call it? Because also for part 1, we also have one-based indexes, and I'm thinking we probably want to use one-based indexing, so that when we go left or up, we go into 0 instead of having to wrap around, like thinking of thinking of underflows on unsigned integers. Although we can also use 0-based positions and then add 1 when doing the final calculation. So I guess it won't be much of a difference, right? Oh man, I'm thinking of if and when this will become a cube. Okay, that's gonna be difficult. And another thing that I would like to decide is whether to model the facing that you have, or the direction that you have, as like an enum of right, down, left, and up, which can conveniently map to these numbers, or have like a 2D vector with your direction. So if you're moving like right, it can be x1 for x and 0 for y, and when moving left, be -1, 0. And that representation could be easier to rotate around, things like that. But maybe I'm thinking too much ahead. Let's map parse map. And we are gonna have a function that will return what? I guess we can just get away with using a vector of something, and that something would be this tri-state thing. It could be empty, or like nothingness, empty and wall. How open is the, okay, so it can be open, it can be wall, and it can be nothing. Or I guess we can also we could also model this with an option of pool, which is also like a tri-state thing. But I'm thinking that if I want to do like pattern matching or something with this, I probably want to use an enum. Okay, so let's call this enum tile, and it can be empty, open, or wall. Right? Does it call this thing empty? Like the nothingness here. You begin, blah, blah. There was a comment that mentioned this. Yeah, here. The above example, row 1 and column 1 refers to the empty space with no tile. No tile it's not a tile, it's no tile. Yeah, it's I think that the description is full of clues to realize that this map is bogus, and the actual thing is a cube. Okay, so we are going to parse this map. How are we going to do this? Well, let's do S lines. We're gonna map each line to something, and we are then going to collect them into a vector directly. And then we're gonna do line. We can use bytes or chars, it's kind of the same. Chars, and map each character to something, and we are also going to collect here. And so let's do match this character. So if it is empty, it's gonna be tile. By the way, these names, I think I want to use them. Use tile. So if it's empty, it's gonna be empty. If it's a dot, it's gonna be open. And if it is a hash, it's gonna be a wall. And this collect complains because, oh no, it's not option bool. It is a tile, of course. And this is non-exhaustive, so anything else should be unreachable. Unexpected character is all right. So there we should have a map. Let's just print this thing for now. Map should be able to print it if this thing derives debug, right? No, not println. This is format, what I want. And if we run the test now, oh, although I don't know why I changed that. I just want to run it print line and just leave the format with nothingness here. Okay, we have panicked assertion. Yes. So does this look like the sample? Should be 8 empties, then open, 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 and wall. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, and 1. Yeah, it looks like it, and it ends with wall and open. So yeah, I sort of trust this. So one thing to keep in mind is that these internal vectors are not going to be all the same length, because the initial strings are not all the same length. But we should be fine with that, I think. And then let's parse the instructions. Let instructions be parse instructions parts. Please generate this. Let's move it around here. So this should be pretty easy, I guess. This will be a vector of instruction, and what is the instruction enum gonna look like? This is just because I don't want to deal with, like, I could leave the map being characters and maybe the instructions being like the single like letters L, like left, right, and blah blah. But I guess these numbers could probably be bigger. Let's check the actual input. Yeah, 31, 16, 40. So they can be at least two-digit numbers. So an instruction can be left or right or advance. So this is forwards, move, and let's say advance, and a given number. So how was U32 is what I want, yeah. And how are we going to do this? So I guess we could split this thing with left and right. This is the kind of parsing that would probably be easier with like a parsing library. Because also in Rust, if you have something like, I don't know, 15L, and you try to parse this as a number, it's going to complain, rightly so. But having some like more relaxed parsing would be helpful here. Like I could try to say, okay, try to parse a number and like extract this, but if it starts with L, then it's not a number. Something like that. How can we do this in a nice way? Because also the split does not give you the splitting things. Oh, but there is a split inclusive. I think this is what I want. Separated by characters matched by pattern. What's that? Oh, leaves the matching parts as the terminator of the string. Yeah, this is not exactly what I want. But if this thing exists, I wonder if split y space, split n. Wait, there is a split n? I thought that I was looking for something like this. Not too long ago. So no, none of this is exactly what I want. I'd like to split by R or L, but keep those things in the array. So how are we going to do this instead? Should I do like a for loop? Good old for loop. Yeah, I cannot think of a better way. So yes, we can say let result be an empty vector for each character in string cars. And also I would need to, not even a for loop is enough. I think I'm going to need a while with an iterator. Beautiful, beautiful. right? Yeah, that's not gonna be nice. You're gonna have a mutable. Oh, by the way, this result is also gonna be mutable. There surely is a better way of doing this, but I cannot think of it. Let's call this thing chars. So for each character in chars, oh, sorry, again, this is not what I want. I want to do while some character is next. I'm gonna do something, and I need to do this because I also want to call next inside when we are parsing a number. I think that sucks. That's quite ugly, right? I do wonder if there surely is a better way of doing that, but I cannot think of it. And it's always alternating, this thing. So I guess we could do the split inclusive trick. We could. And then leave the last one. Like if we do a split inclusive with R and L, we're gonna get a string with this, a string with this, a string with this, then this, and then we can split that again. Or I guess take the first part and parse it as a number, and then the other and parse it as an L. Well, let's keep this. Let's continue with this manual while loop idea. So this is a while let character. Then it's gonna be. I want to see the type. Yeah, this thing is a type char. So we can say match let's instruction be match character, and if it is an L, then it's gonna be, I guess here we can also say use instruction everything. It's gonna be left. I guess the instruction could be turn left, because if we are going to, I guess maybe for instructions, let's not have this use. Let's use the full namespace. So if it is right, then right, and if it is a number 0 to 9, then we are gonna do something different. We're gonna accumulate, I think. Yeah, it's like a take while what I want to do. Yeah, so this is like more like a custom splitter. So here we did next, so we have already advanced the iterator. I think that there should be a take while, which we could do like, okay, take while it is what does this return, by the way? Take while. Iterator that yields element-based predicate. I'm not sure if take while is what I want to do here. You can say let S be a string. Do we even need to annotate? Yeah, no, this is horrible. It's like this is something that I don't want to do. From can I make a string from a character at least? It's complaining because yeah, no, because the match arm is not that, but this is surely not the best way of doing this. What do I want to do here? I want to like peek at the next and see if it is a number and then advance, right? That sucks. I think I will need to wrap this iterator into a peekable iterator. Is there some kind of like split width or something? Splits. What is something like split terminator? That sounds pretty badass. Or a function or closure that determines if a character matches. Huh. Equivalent to split, except that the trailing substring is skipped if empty. Wait. So split also can take a function? Or a function, yeah. Hey, look at that. How does is uppercase? So that's another idea, I guess. Right. I feel like I am getting like how do you say, like I am drowning in a glass of water. Like there must be a very easy way of doing this split that I'm not seeing. Is there such a thing as Rust split by word boundary? There's a words thing. Interesting. Is there words? What does words do? Maybe it's not a stable thing. Yeah. Okay, there are word boundaries in regexes, but I don't want to use regexes. There's also zipper iterators. If we have chars, can we do some, like, no, not inspect, but intersperse of other things? Why is this so complicated for me? What am I doing wrong? What can I do to make this easier? So if we split by numeric, we're gonna miss this. Yeah, you know what? Let's forget about this idea. let's do something simple, like I don't know, just return an empty vector here and print what happens if we do chars split. No, sorry, what I want is string to split by L or R, and actually I want a split inclusive, because I'm feeling like I am really complicating this way too much, and we have to collect this into a vector. Although, can we inspect this thing? What does inspect do? No, it's not what I want. Collect into a vector of you don't like this because does not implement display. Of course, you need to be like this. This is what we get: 10R, 5L, blah blah blah. And this was inclusive, and it includes the last new line for some reason, which is this. I guess I could exclude this new line because the new line was inserted automatically by my text editor, but the inputs could not have it. And in this case, it would be like this. So, fine. And then I guess we can split both of this. Yeah, we can iterate over this to sort of a flat map or something. Right? Kind of. I mean, it's not really what I want. Is there a split that is like split include separators? But put the separators in like a different thing and as a different elements. Yeah. Yeah, I guess if we, I don't know, I'm thinking of different possibilities of doing this, like using a take while is numeric and take while it is L or R, you know, those kind of possibilities. But everything sounds kind of ugly. So like the pattern that I want, it's more like, I think it is more like a regex-based thing. Yeah. Yeah, I don't know. I'm getting really distracted by this and by this parsing. Stupid brain that sometimes gets really hooked up in some specific problem. So what I want is what exactly? You could probably use this split inclusive, and yeah, it's not something that I love, but let's go with it, and we can find a better way of doing this later on. So let's do something similar to what we were doing before, of having like a mutable result and blah blah blah. And we are gonna return this result, but we're gonna just do a for loop over, so for each string, or let's do part in split inclusive with this. We are gonna do what? We have to then split each part between the numeric part and the left or right part, right? So we can do something like part characters, take while. Does this make sense? Let's do it very stupidly. If part ends with, and here I guess it has a pattern, so we can use the same pattern. Beautiful. With L or R or R, we are gonna do something. And by the way, this inclusive thing, well, let's leave it like this. Yeah, let's leave it like this. If it ends with L or R, we can have the numeric part is going to be the first part. So let's end the part from 0 to part length -1. We're gonna parse this, and we're gonna do res push instruction advance n. And we also have the left or right, so let's do match part we need the last character, I guess. So can we do something like this? Last, but this is an option, and We already know that the last is this, whatever. If it is an L, then we're gonna do instruction left. If it is an R, we're gonna do instruction right. This is a match. This is fine, and we're gonna do res push of this match thing, and else. If it doesn't end with that, it should be like this, but not any substring. Does this work? Oh yeah, parse. Expect beautiful repeated code. Okay. And then this non-exhaustive, of course, unreachable. So unexpected character this. Okay. Can we maybe print line these results and see what the hell we are dealing with? Of course, this thing does not implement debug, so let's derive debug for this. Ah, man. Okay, so we have something, and it kind of looks nice. If we take a look at the sample that we have, it is advanced 10, right, then advanced 5, then left. Okay, yes, it looks, and it ends with advanced 5. And what happens if I save this file and I have a new line there? If I do character test now, it fails. Beautiful. With an invalid digit, because it doesn't like that that new line. You know what? I'm going to just trim this or strip. Isn't there a strip white space? Split white space. String strip white space. Come on, there should be a trim. Wait, there is, and I wasn't finding it. Oh yeah, trim. Yeah, trim the end. I don't know. With this, I expect this to not fail. Well, it fails because it doesn't match the expectation, but it did the parsing all right. Okay. So this is horrible to do. Find a less horrible way of parsing this. Okay, but at least we did the parsing, which took way too long. I think it's over an hour. since I started and I only did the parsing. So can we try something to have part 1 and read what part 2 is about and maybe discover that hopefully maybe it's not a cube, I don't know. So how are we going to do this? Okay, let's code this logic here. We're gonna iterate over the instructions. So let's say that for each instruction in instructions, we're gonna do something depending on what it says. So turning left and right is going to be the easiest to implement, and then advancing is going to be the hard one. So we are also going to need a mutable position. So I guess we can have something like x, y coordinates. Can I have something like this? We can start at 0, 0 or 1, 1. Let's see what happens with 1 based indexing. Doesn't like this because it's probably another syntax like this, mutes, beautiful. And also direction or facing, let's call it direction. It's gonna be something. It starts at right. I think I'm going to try out doing this direction as an enum and then seeing if it makes sense to as that. So this, let's change the instruction to say turn left and turn right. There is one thing that I would like to know about enums. Can we Rust integer to enum? I think there is a converts integer to enum. This is, I know that enums can be converted to integers. That's fine, but the other way around. Blah, blah. Come on. It's not as easy, it seems. Why do I want that? Because if we have the enum defined as something like enum direction, be right, down, left, up. So it's turning clockwise, and I think this thing said that it's 0 for right, so we can say, okay, it's 0 for you, and then 1, 2, 3. Turning clockwise is like adding 1 to this, wrapping mod 4, and then converting that into a direction, which is all right. But it doesn't seem like there being like a simple way of doing this. Like this is not C. And we need a match. That's beautiful. Non-derive, an external dependency for this. That seems harder, better, safer, rustier. Beautiful, beautiful. Yeah, I mean, let's go with this and see what happens. So this direction we can use direction. Okay, so we have the initial direction and the initial coordinates. What do we do? Well, we're gonna do something depending on this instruction. If the instruction is, I guess we can also use this instruction. We have quite a bit of enums here. We can probably get rid of this and make this mess a little bit less ugly. So if it is turn left, we're gonna say direction turn left. And look at that, that's object delegation. If it is turn right, we're gonna say direction turn right. And if it is advance a number, that's the tricky part. Let's leave it unimplemented for now. Let's implement these guys. So generate this thing. Yeah. So how do we turn left? And similarly, how do we turn right? Oh, by the way, yeah, this should be, I think, an assignment to direction instead of a mutation. So this should, let's start with turning right because I think it's gonna be slightly simpler. So we're gonna do self as just as a number. So let's say as a byte or whatever. You thought it's like whatever, yeah, whatever. These mod 4, and of course this will complain. Like, does it know something? No, like you cannot turn a number casting a direction as U8 is invalid. Okay, now that is expected direction found. Yeah. So we can have something like direction from number, or just from. I wonder if this makes any sense. I could also write the 5 matches here, but let's say from number, and we said that this is U8. It's gonna give me a direction, and it's gonna do match number. If it is 0, then right, and we have 1, 2, 3 down, left, and right. Okay, this is probably non-exhaustive, so it's going to complain, but it's complaining about something else. Turning left. Oh, by the way, this is, I'm not changing anything here, so I should say self as U8 plus 1 mod and then this. So in Rust, when you say -1, you get, well, this is a U8, but if it were signed and you get a -1 here, -1 mod 4 is -1, which is not what we want. So I think a simple way of doing this is doing +4, like this. And this complains because what? I found direction, yes, because this should return a direction. Beautiful. So cannot move out. Is behind a shared reference. It should implement copy, of course. This is a simple enum, so let's do derive copy, and copy needs clone, and this of course this should be mutable, and let's print the final direction. Println final direction is dir, and we will also implement debug, I guess, for this. So much stuff. Warnings, warnings, warnings. Could not compile due to error. Okay. Yeah, we have a non-exhaustive. Yeah. From 4 to maxint. So anything else is unreachable. So invalid direction number. And you're complaining because that's not an underscore. That is an underscore. Run the test now. Final direction is right, which is the same as the starting one, so that doesn't tell us much. Let's print the direction like this. Okay, so it's turning directions, so that is fine. Okay. Then we have to advance. That is the juicy part. How are we going to do this? So when we advance, we should increase, like change the position, I guess, and wrap around the map, do the wrapping if necessary, then check if there is a wall there, and if there isn't, then we move there, something like that. Right? I think so. So how do we do that? Well, first let's we don't want to mutate these variables directly because there might be a wall, so we're gonna have maybe a copy of them. Let's new x be x and new y be y, and these things are gonna be mutable. And then we're gonna do match our current direction, and if it is, let's do the usual logic here. By the way, can the language server do this for us? Yeah, look at that. If it is right, then new x plus equals 1. If it is down, then new y plus equals 1. If it is left, new x is minus 1. And if it's up, then new y is minus 1. Okay. Then we have to check the map. Yeah, what do we want to do? We have to wrap around if necessary. Right, and then get the position. Oh, and by the way, advance, we have to, it's not just +1, this should be a loop. This should be a loop of n times doing this thing. So okay, we're going to wrap it in a loop later. Fortunately, the compiler tells us, hey, you're not using n, that's probably an error, and it is. So what do we need to do then? Let's say, is it wrap or teleport, or how this is called? No, wrap around, okay. Wrap around. We can pass the new x and new no, I think does it make sense to do this? Because with the new x and new y, I don't think that you can know how to wrap around. You also need the direction, I think. Yeah, I'm pretty sure you do. Because, for example, if you are, imagine in this example, you want to move up here, it's the same as if you wanted to move left from here. So you have to know which direction you are going into the void to know how to wrap around. Right? I think so. Oof, this is complicated, man. Or maybe today I'm not just I'm not very inspired. I feel like this is being way more complicated than it usually is for like grid-based problems. I am also questioning my decision of using direction as an enum, because now when wrapping around, we're also going to have to check the direction that we are going, and we're gonna need to do something similar to this, I think. Yeah, it's not very nice, I think. Well, let's bite the bullet and continue on. So we're gonna pass these two as mutable references, so this thing can modify those. Can modify this and the current direction that we are moving in. Right? So wrap around. Please generate this. Beautiful. So it inferred some things that might not be true, but and we will also need the map, of course, the direction and the map. Look at this beauty. Let's have a type definition for the map. Let's put the type over here. And this will see a reference to the map. Okay. And this will return nothing, I think. I don't know why it didn't infer, like, hey, this doesn't, like it generated incorrect parameters. So there should be a mutable reference. Should we use i32? We're gonna be accessing the map with this. So I think I want to just try out to use size and not do too many conversions. Direction and map. Okay. So, wrap around. How do we do this? We can do well, if let's take advantage of these things starting at 1, 1. So now they could be 0 because we have decremented this. So if this is 0, or I want to check, like, if it is on a correct position, then it's fine. Like if it's not empty on the map, right? So if the new x is 0 or new y is 0, or set or map get we want to get so this is if it is out of bounds, in this map first we need y, right? This is the line, so this should be y minus 1. This is an optional, so we can say, and then row get new x. These variable names are not very good. Minus 1. This whole thing I want to check if it is empty. So we cannot do a let here in the middle of this chain, but I want the result of this, but only if these two are in bounds. So how can we say that? Let's say this is let out of bounds. It's gonna be either this or this. Yeah, I guess. getting this is conditional to that. So okay, and then blah blah, get this. So it's out of bounds if this is some and no, actually we can also go out of bounds to the right. So if it is none, we're also out of bounds. Why is this so complicated? I'm getting really stupid with this. So yeah, I think we can wrap X and Y around. Yeah, we can probably do that and not check for 0. And then they are always valid U sizes. And then we can get these and check if it's none or if it is some empty. And then we know that it's out of bounds, right? Yeah. So yeah, let's say instead of doing this, let's do wrapping sub 1, and this same thing, wrapping sub 1. We don't need to check this. Let's say let's tile is gonna be this. So the type of tile should be an option, yeah, option of tile. So if if the tile is none or some empty, we are out of bounds and we need to do something. That is, I think, what I want. It was so difficult to write this. So yeah, this is the condition. We are out of bounds and we need to find the new position, right? So we're gonna turn around the direction and we're gonna walk in a similar way as we walked here, and we're gonna do that while the current tile is is either open or wall. And actually, if it is wall, we shouldn't check that. Why is this so complicated? Complicated. Okay, one thing that we could do here, maybe to express this better, is to say or like unwrap OR. So if it is none, then I want to be empty, right? So that is something, I think. Yeah, so if this is empty, then we're out of bounds. This is surely not the best way of doing things. But well, let's see, I guess. You are complaining about this because cannot move, share reference, because direction is probably not copy. No, but it is. What's your problem? Oh, tile. Tile should be copy and clone. This is the problem of modeling everything with enums, is that they don't behave as well as like the primitive types, integers, and you have to derive a lot of things. All right, so if it's empty, then we want to wrap around. How are we going to do that? Let's do, let's get the opposite direction of what we are doing. So let opposite direction be, and how do we get the opposite of one direction? Well, I guess we can turn right twice or turn left twice. Let's turn left because it's shorter. And then we are going to walk in this direction while getting, so this logic here is like get the position without wrap, like get what is on the map without wrapping. Okay, so we are gonna do, I guess we can just mutate these things. Although no, we let's call this thing X, Y. They are mutable. We're gonna wrap around. Actually, like the wrap around, it's maybe would be better if instead of like modifying this thing, it just returns the wrapped coordinates, so that then you can then you can check if it is a wall, and if it's not, like don't move, not move. Maybe it makes more sense to do that. Yeah, this is so so messy. But let's carry on forwards. So we're gonna do this on a while loop. While it is something. But we are already out of bounds. So we should like do one movement in the opposite direction that will put us in bounds. Yeah, you know what? This doesn't really make a lot of sense to me. all of this approach is a bit bogus, I think. because now we are about like out of bounds, but does it make sense to even do this? Well, let's just try to. We're gonna do something like this. We're gonna do this in a loop. We're gonna match the opposite there. And yeah. Although instead of turning this, we could have then like the logic for there and going the other way around. That's okay, like we have the opposite. We're gonna do this, and if getting this new x and new y is empty, we're gonna break, I think, out of the loop. And that is it. Right. So let's call this kind of thing running around sub1 and blah blah blah. Let's call this passing, well, it should be x, y, and map. Let's say get tile non-wrapping, very explicit name. We're gonna receive x and y and map. It's gonna return a tile. Sure. This is gonna be non-neutral stuff. X and y map. Okay. So sure. You know what, just pass new x and new y here, and let's make this function return new x, new y. Can we do this? Yeah, this thing is gonna return usize, usize. Oops. And this complains, and if it's in bounds, we're gonna do something like that. Here we are incrementing, we're trying to walk and trying to see yeah, this is also not very pretty, because we want to advance and check, and if it's and if it is not empty, then advance, otherwise we keep being there. So I guess we can say something like very similar to this. X blah, which we are going to start as x and y, but this is gonna be the new and new. We're gonna do something like this. You don't like this because new view size. Yeah, no, but I don't want you to be this. I just want you to be like this. Okay. So we're gonna try to walk, but the problem is that if I if I get into an empty state again, it's like I shouldn't update this guy. So why is this so complicated? I'm really feeling unfocused today. Can we say something like this should be much simpler. This is like the new thing that I want them to be. I guess we can actually alias this, shadow this. That's not a good idea, but bear with me. So new x and new y. Here we have to increment x. So we're gonna do just x plus 1 and y. Here once we increment y, so which is gonna do x, y plus 1. And here we're gonna do left is x minus 1 and y. And here this thing is x, y minus 1. And if get side non-wrapping new x and new y with this map, if it's not empty, and I don't think we can do comparisons like this, then xy actually, if it is empty, we had to end iteration, right? So if it's not empty, we will assign it. Yeah, okay, so if it is empty, then we will return x and y, this mutable x and y. Otherwise, we're gonna assign x and y to this new x and y. And sure, you don't like this, we can also rewrite this as saying let empty be this, so whatever. Does this make any sense? Okay, we are wrapping around. We are reassigning this stuff. Beautiful. And then with these x and y, which we haven't touched the originals, we actually want to know if it's a wall. And if it is a wall, we don't move there. So if let's get tile non-wrapping new x and new y of map, if it is a wall, then we're gonna break, I think, this advance n, which is not inside the loop, but we should break. Like, let's put this into a loop for in 0 to n. Okay, save format. So if it has a wall, we stop advancing. Otherwise, we're gonna do xy equals new x new y. And this was such a mess to write something pretty simple. But did we succeed? Is this an answer that makes sense? So the correct answer was something like 1,000 times final 1,000 times the row, 4 times the column, and the facing, the direction. So row is y. I should probably have called this, instead of x and y, row and column, but anyways, so 1,000 times y plus 4 times x plus direction as, well, let's say u size, because x and y are u size. And let's put answer 1 here. What do the tests say? Did the test pass? Oh man, did I implement this shit correctly? Like if I say what here, does this break? Yeah, we got it. No, I cannot believe it. It doesn't even make sense. We are printing this and we have warnings. Like, how can it be that the up direction is never constructed, never used? That doesn't make sense, right? But the test pass? What happened here? Really, what happened here? How is direction? Oh, what the hell? How can this have worked if we don't have, like, right, down, left? This should be up. But still, like, that warning made a lot of sense. But this still I'm very confused about this. It seems we never went up. No, it seems like in the example we never go up. So that path of the code was never executed. But it was a clear bug. Wow, thanks Rust for the warnings. So okay, that was cargo test. Can we run the day 22 with the real input and get no, it panicked with an underflow. We went below 1. Very interesting. So in the example, we never go left, like from 1 to 0, but oh, this is y, so it's going up, and it should start on the other side. But why do we get to here? Like, surely when this is 1, we have to do the wraparound thingy. And if it is, like, if y was 1 and I guess we can do something like this and let these things not be mutable. But anyway, if y was 1, no, yeah, okay, if it was 1, when we say wrap around, it should get this non-wrapping thing should return empty, and you should say, hey, no, it should be here, and it should go down until we find an empty thing, right? Let's maybe try this with a sample. So we are starting here. Instead of turning right at the beginning, let's turn left and go up, because maybe the sample is gonna be yeah, sample. Let's turn left at the beginning and let's run cargo test. Yeah, it fails, but we are not exploding. Interesting. I wonder if when running the tests, there should be debug checks, but I'm a bit suspicious about this, so I'm gonna fall back to what I've always been doing and replace the input here. Did I change? I did something stupid here, right? Yeah. Okay. If we put the thing here, we get this. If we turn left in here, does it explode? No, it doesn't. Okay, so it's not a matter of underflows not being checked or something like that. And of course, if we, oops, now we can do it like this. We are getting to here, so this is 0. But how can it be 0? So I don't know how many iterations we are gonna get here. Let's print something. Advanced from to and this is gonna be xy and new x, new y, and this probably needs debug annotations. Maybe also print when we are turning left or right, because that might help. Println turns left. And turn right. Okay, so we are advancing. This is the first move, it seems. So it's 32 moves. Sorry, it's 31 moves to the right. We got here. It turns left, but oh, it shouldn't have written this 32, right? Shouldn't have wrap around. So if it is a wall, we break. why did we get to 32 if we moved? Well, we moved 31 times. Yeah, we should get to 32. That is correct. And if we check this, well, it's kind of a mess. We can see here, if we have my face. Come on. Do we have tiling for down? We don't. Okay, we can move this around here. We're moving 32. Oh, there are walls. We should have gotten to a wall much sooner. So that's a problem. But how did how did the sample work if we are like we shouldn't be starting at 1, we should be starting at the first row, like the first non-empty, first open thing on the first row. So that sucks. So it should be, let's separate this into 2. Well, let's say x is something, y surely will be 1, but x, let's say map the first row, and let's do what? Like it's really weird that that the sample worked, but no, I guess it did. What do we want to have? We want to iterate over this, over the row, and we're gonna have gonna enumerate, I guess, enumerate, and find the first tile. So we're gonna have an index. I don't know, we can use position, right? Yeah, the position of a tile that matches tile open. Okay, and we should just unwrap, and this is 0 based, so it should be 1 based. And let's println initial position. It's gonna be xy debug mode. Okay, so if we run the test, running one test, why don't I see any output? Does Rust only print the output when the test fails? So if we make this fail, do you print? Oh, interesting. Okay, the initial position is 9, 1, which I think is correct, because yeah, we have 8 spaces and 9. So now the test should run correctly. And let's see if this explodes now. It didn't explode. We did get an answer. Let's try this answer out. And yes, okay. Finally. We get a golden star for the first part. which I assumed was easy. And I'm dreading a little bit to read the second part. So, yeah, I think I'm going to be cutting it off, but let's read the description of the second part first. As you reach the force field, you think you hear some elves in the distance. Perhaps they have already arrived. You approach this strange input device, but it isn't quite what the monkeys drew in their notes. Instead, you are met with a large cube. Each of its 6 faces is a square of 50 by 50 tiles. Okay, yes. Our assumptions were correct. To be fair, the monkeys map, I like that at least 50 by 50 is hard-coded, so we can probably assume some things. The monkeys map does have 6 50 by 50 regions on it. If you were careful to fold the map, you should be able to shape it into a cube. In the example above, the 6 smaller 4x4 faces of the cube are these. You still start in the same position and with the same facing as before, but the wrapping rules are different. Now, if you would walk off the board, you instead proceed around the cube. From the perspective of the map, this can look a little strange. In the above example, if you are at A and move to the right, you would arrive at B facing down. Yes, okay, because this connects to this, and so this is like a teleporting from here to here facing down. If you are at C and move down, you would arrive at D facing up. Look at this, very interesting. Walls still block your path, even if they are on a different face of the cube. If you're at E facing up, your movement is blocked by the wall marked by the arrow. So we are at E and we want to move here, but there is, this wall. Okay. Using the same method of drawing the last facing you have with an arrow on each tile you visit, the full path taken by the above example now looks like this. So we start like this, we go like this, then this connects to here, then we go like this, and this connects to here, go like this, this connects to, this faces the wall, so it stops there. The final password is still calculated from your final position and facing from the perspective of the map. Okay, in this example, the final row is 5, the final column is 7, and the final facing is 3. So the final password is this. Fold the map into a cube, then follow the path given in the monkey's notes. What is the final password? Yes, okay, it is exactly what we thought it was going to be. So I'm definitely not going to do this now because my brain is a bit melted. Like part 1, which was much easier, took me such a long time, and I think this can be simplified to almost nothing. So I realized that I'm not really in a very focused state, so it doesn't make sense to try part 2. I will keep thinking about this because it's a very interesting problem. I wonder, how are we going to model this? Like, maybe we can keep the 2D map, and when we go out of bounds, have a some sort of complicated logic to know which face connects with this, and how the rotation is made. Or we have to model this in an actual 3D thing. The thing that I'm also worried about is that the wrapping of this cube, the shape of this is different than the shape of this. So cubes can have like different wrappings. We can search for, I don't know, all cube wrappings. I don't know how is this thing is called. Yeah, no, I don't want wrapping table. And foldings. Oh, yeah, exactly this. These things are all the different cube, the ways you can unwrap a cube, and all the rotations, of course, and probably also like reflections of these things. So we can see that the one in here looks, I think, like, how does it look like? Like it's a T with a thing on the top. So it's like this, but rotated. Yeah, it's exactly this, but rotated 90 degrees clockwise. And mine, I think it is, yeah, snaky thing, which is this, rotated and flipped and whatnot. So the thing that I think might be very complicated is like knowing how to parse this map into a cube. And maybe we can cheat a little bit and assume that the shape of our input is exactly this one. So we sort of assume these positions of the faces, and then know how to connect between each other. I don't know. We can do something ad hoc for our input. I don't like doing that. Like I would like this to be pretty generic, but you know, if need be, I guess that would be possible. But yeah, that's definitely not going to be something that I will be trying out today. So I will leave this as it is now. I will probably keep thinking about this in the background of my mind, but for now, that's the end of the video. If you haven't, thanks for watching and see you later. Bye bye.